Hi, so I want to do a proof of a particular problem that's probably the hardest problem I've ever given on a final exam, or any exam for that matter, which is the language of all strings with A's, B's, C's, and D's in that order, and the total number of them is a multiple of 27. So what I asked my students was, classify what this language is. Is it regular? Is it context-free but not regular? Or whatever it is? So it's pretty obvious that it's decidable because I can just make a count of all the characters that I see, and I figure out, okay, is it a multiple of 27? The problem is it regular or not, or context-free? So what I'm going to show you here, believe it or not, is that this thing is regular. And it's actually very hard to see this, but the proof is really cool. So the problem is that I can't just make a little state machine that goes in like in a circle of length 27, because we have to have the A's first and then the B's after, and then the C's after that, and then the D's after that. So it has to be in a certain order. So the way to think about this is I only really care about what the current remainder is when I divide by 27. So no, 27, there's nothing special about that number. I can replace it with 5 if I wanted to, but let's just stick with the original problem. So then here, let's just say I read A's. Well, I don't know how many I'm going to get. It doesn't have to be a multiple of 27, but whatever its remainder is, the rest of the string has to make up the rest of the remainder, whatever it may be. So then what we do is, okay, we figure out what the remainder is after reading A's, zoom over to the B's, and then figure out how to determine the remainder after reading some number of B's, and then go to C's, and then go to D's, and then have the state that corresponds to a multiple of 27 so far be the one for the one they accept state in the D cycle. So here's the main idea. So what I'm going to do is I'm going to have in blue the A machine, so to speak. So I'm going to make a giant circle right here. And it goes all the way around. And it's going to go like this. So that's the A machine. So this is the A, or A part, I guess. Then what I'm going to do is I'm going to label each one of these. So call that 0. That's not a final state, by the way. So 2, 3, up to 26. And so that's representing what the current remainder is when dividing by 27. So then what I'm going to do is actually I'm going to copy and paste this guy. Copy, paste. And change it to green. And this is going to be the B part. And so I'm going to still have 0, 1, 2, 3, but this is not the start state anymore. This one will always be the start state. So then now what we do is, okay, let's say we're right here. We have a multiple number of 7 number of A's that we've seen so far. Actually, I should change all of these to B's. So all of these are going to be B's. Then what we do is we say, okay, well, if we have exactly this number of 20 of A's so far, then if I want to start reading the B part, then I should go to the corresponding state over here. So what I'm going to do is I'm going to supplant this with epsilon transitions. So the 0 goes to 0, the 1 goes to 1, etc. So then the 3 obviously will go here. Oops, that should be a better epsilon. And then the 26 will go to right here. Okay, so then if we decide to jump over to here, then that means that we'll start with the current the current remainder when dividing by 27, which is 0. And then I'm going to do some way around this machine. And then at some point I'm going to have a, let's say, yellow, one for C's. So we're going to have a giant circle here. So C, C, like this. And let's call these 0, 1, 2, 3, up to 26. So this is just the idea. I'm not actually naming these states these names. This is just the idea. Then we will go from the corresponding state over here to the corresponding state in the C machine. So the 0 goes to 0, the 1 goes to 1 as an epsilon transition, 2 goes with 2, 3 goes with 3, like this, and then 26 goes, oh boy, goes with 26. And then finally, I will do the same logic with the D's. So I'm going to have a 0 state, a 1 state, let's just do 2, and then 26. So this one actually is an accept state. That's the only accept state in the entire thing. So these are going to be D transitions. And what we're going to do is exactly the same idea. So we're going to have an epsilon transition from 0 to 0, 1 to 1, and then 2 to 2, and then 26 to 26. So we're keeping track of the current remainder and then just zooming over to the other machine in the exact same place if we decide, okay, non-deterministically, I'm going to start the next character. And we're keeping track of what the current remainder is. So this is a horrible looking machine, but it's an NFA, so we can convert it to a DFA. And so this language is in fact regular. So hopefully that was interesting. Leave comments down below about this problem and regular languages in the comments down below. As always, please like the video and subscribe to the channel. It really helps us out. There are many other links in the video description if you want to support the channel further. And as always, thanks for watching, and I'll see you next time.